Hello, we are Team 2 and I'm going to explain the exercise 4 of the activity 8. The instructions are solve the following differential equations with constant coefficients using the initial conditions when given, and we have two differential equations. This is our first differential equation and we have two initial conditions. To solve our differential equation, we first apply the Laplace transform of our differential equation to obtain in terms of the domain of S. After apply the Laplace transform in our differential equation, we substitute the values of each initial condition in our differential equation respect to S, and then we factorize some terms to obtain the value of the function y of S, and we must obtain a proper fraction. The partial fraction that we want to expand is 1 plus s squared plus 10 times s over s times s plus 4, or raised to the square, and we want to know three values or three terms to solve our partial fraction. To know the first value, the value of a, we apply the limit when s tends to 0 of s times the partial fraction, and the term of s is eliminated, and then we substitute the value of 0 in our partial fraction, and we obtain that the value of a is 1 over 16. Then we want to obtain the value of b2, and we apply the limit when s tends to minus 4 of s plus 4, or raised to the square, multiplied by the partial fraction. S plus 4 is eliminated in the partial fraction, and then we apply the value of minus 4 in each s, and we obtain that the value of b2 is equal to 23 over 4. The next step is apply the limit when s tends to minus 4 of the derivative respect to s of the partial fraction times s plus 4 raised to the square, and the terms of s plus 4 is cancelled out, and then we apply the derivative, and then we substitute the value of minus 4 in each terms of s, and we obtain that the value of b1 is equal to 15 over 16. Then we substitute the values of each term of the partial fraction expansion, and we obtain that the value of the function y of s is equal to 1 over 16 times s plus 15 over 16 times s plus 4 plus 23 over 4 times s plus 4 square. After that, we can apply the inverse Laplace transform, and we apply in a term the shifting property, and then we can obtain that the function y of t is equal to 1 over 16 plus 15 over 16 times the exponential raised to the minus 4 times t plus 23 over 4 times t times the exponential raised to the minus 4 times t. Now this is our second differential equation. It's a similar differential equation, but is equalized to t. And our initial conditions are equal to 0. Then we apply the Laplace transform in our differential equation, and in our functions respect to s, we eliminate all, all terms that have initial conditions because they are equal to 0. Then factorize y of s, and the terms of s are passed to the other side to obtain our partial fraction, that is 1 over s squared times s plus 4 squared. And in our partial fraction expansion, we want to know 4 different terms to solve it. The next step is obtain the values of a1, a2, b1, and b2. To obtain the value of a2, we can apply the limit when s tends to 0 of s squared times the partial fraction. The terms of s squared are eliminated, and then we apply the value of 0 in the s, and we obtain that the value of a2 is equal to 1 over 16. Then we want to know the value of a1. We can apply the limit when s tends to 0 of the derivative respect to s of s squared times the partial fraction, and the terms of s squared are eliminated, and then we apply the derivative of 1 over s plus 4 squared. Then in the derivative we apply the value of 0 in the letter s, and we obtain that the value of a1 is equal to minus 1 over 32. Then we are going to obtain the value of b2. We apply the limit when s tends to minus 4 of s plus 4 squared times the partial fraction. The terms of s plus 4 are eliminated, and then we apply the value of minus 4 in the letter s, and then we can obtain that the value of b2 is equal to 1 over 16. The last value that we want to know is b1, that is equal to the limit when s tends to minus 4 of the derivative respect to s of s plus 4 all squared and times the partial fraction. The terms of s plus 4 are eliminated. Then we apply the derivative, of 1 over s squared. Then we apply the limit, and the value of minus 4 in the s cube, and the result is 1 over 32. Now we have the value of each letter, and we can know the partial fraction expand, that is minus 1 over 32 times 1 over s plus 1 over 16 times 1 over s squared plus 1 over 32 times 1 over s plus 4 plus 1 over 16 times 1 over s plus 4 squared. Finally, we can apply the inverse Laplace transform in our partial fraction expansion. In the last term, we can apply the shifting property, and the result is that the value of our function y of t is equal to minus 1 over 32 plus 1 over 16 times t plus 1 over 32 times the exponential raised to the minus 4 times t plus 1 over 16 times t times the exponential raised to the minus 4 times t.